already told you that I am going to discuss about Kirchhoff's current law. Then we will discuss about that is Kirchhoff voltage law. Okay. So first of all, let me talk about Kirchhoff current law. What is actually Kirchhoff current law? First of all, you have to understand that it is current law. Okay. So it says that the sum of the current entering a node should be equal to zero, or sum of the current leaving a node is equal to zero, or we can also say that the sum of the current leaving or is equal to sum of the current leaving is equal to sum of the current entering a node should be equal to should be equal, okay, each other. Okay, so this is node. According to the diagram, this is node, and I1 is the incoming current, I4 is the incoming current, I2 and I3 are the outgoing current. Okay, so you have to understand that according to the Kirchhoff's current law, we can write down that sum of the current entering, sum of the current leaving, that are I2 plus I3, is equal to sum of the current entering a node, that is I1 plus I4. So that's why we can write down I1 plus I4 is equal to I2 plus I3. If we talk about the applying of the formula according to this definition, sum of the current entering a node is equal to zero. Okay, so just consider that all the currents are incoming. Okay, if I am taking positive sign for the incoming current, then I have to take the negative sign for the outgoing current. Then negative sign, considering negative sign for the outgoing current, that means I am considering that as a incoming current. Okay, but I am using negative sign because the current is actually outgoing. Okay, so sum will be I1 plus I4 minus I2 minus I3, because if I am taking positive sign for incoming current, then for outgoing current I have to take the negative sign, that is minus I3. Same negative sign I have to use with I2, so I am using here minus I2, and I4 is the incoming current. As I have used positive sign for the I4, so I have to use the positive sign for the I4 also, I1 and I4. So that's why I can write down I1 minus I2 minus I3 plus I4 should be equal to 0. According to the second definition, that sum of the current leaving a node should be equal to 0. Like I am considering that the current leaving a node will be used as a positive sign, so that's why the current with negative sign, only negative sign will be applied to the incoming current. Okay, so here I1 is the incoming current and I am applying the concept for leaving a node. Okay, so I1 will be used with negative sign, so I have been using here minus I1. As I4 is the outgoing current, I2 is leaving the node. Okay, that's why according to this concept I will use positive sign plus I2. Same concept I will use with I3, that is plus I3, and for I4 as an incoming current I have to use minus I4. So that's why with the definition, so that's why the expression will be minus I1 plus I2 plus I3 minus I4 should be equal to 0. So this is the current Kirchhoff's current law, and this law will be definitely helpful for you if you really want to find out the desired value in any electrical network, or just want to solve any electrical network analysis. At every node you have to apply the Kirchhoff's current law. That is very much important formula, and that is very much important law conceptually wise, if you really want to follow and if you really want to solve the entire or any tricky network. Okay, and this is the expression for like n branches are there and nth current are incoming and outgoing. So same concept we have to apply here according to this formula. Now talk about Kirchhoff's voltage law. This is Kirchhoff's voltage law, and this voltage law shows that it says that sum of the voltages around a closed path should be equal to 0, or sum of the voltage drop should be equal to sum of the voltages rises. Okay, first of all you have to understand that this is the entire electrical network circuit I have shown here. VDC is the voltage source minus 2 plus, R1 and R2 are the resistance I have connected in the series, V1 and V2 are the respective voltages drops across R1 and R2. Okay, so I have to apply the Kirchhoff voltage law. First of all you have to understand that to apply Kirchhoff's voltage law, the circuit should be closed in the nature. Okay, then only you can apply the Kirchhoff voltage law. Okay, and here now according to this expression you may confuse that why I am using minus here, why I am using plus here. So when you start in the clockwise direction, I have already told you assign a positive sign to the voltage across an element if the plus side of the voltage is encountered first, and assign a negative side is negative if negative side is the encountered first. When I start here, then in the moving upward, negative sign is encountered first, and while crossing the resistance R1, positive sign is encountered first, and here also positive sign is encountered first. So that's why for V1 and V2 I have used positive sign, that is V1 plus V2. When I start here, negative sign is encountered first, that's why I have been using here minus V of DC. So definitely the expression will be minus V of DC plus V1 plus V2 should be equal to 0. So that's why VDC will be equal to V1 plus V2. Okay. So if V1 is equal to 10 volt and V2 will be 10 volt, so definitely VDC will be 10 plus 10 is equal to 20 volt. Okay, so this was the Kirchhoff voltage law as well as the Kirchhoff current law and Kirchhoff voltage law. Both laws are very important. If you will face any question in the gate, in ESE and in other technical examination, you will definitely face such kind of questions that are based on using the concepts related to the Kirchhoff voltage law and Kirchhoff current law. Now come to the example. Okay, through this example, your KCL and KVL and KCL that I have already explained. Okay. So this concept will be so the entire concept will be definitely cleared by using the concept of KCL and KVL in this circuit. Okay, this circuit, actually you have to understand that what is actually this circuit. V of DC is the voltage source, that is equal to 120 volt. R1 and R2 are the resistances, each equivalent to 10 ohm, and the 50 ohm are connected in the series. I am considering I1 current flowing through the resistance R1 and I2 current flowing through the resistance R2. V1 is the voltage drop across the resistance R1 and V2 is the voltage drop across resistance R2. Now I have to apply KVL and KCL, both rule here. So this is the entire closed circuit, so I have to apply the KVL rule in the clockwise direction. So when I start from here, negative sign is counted first, so that's why I have been written here minus 120. Okay, now for this resistance I have to use the voltage drop. Plus sign is encountered first, that's why I have to use plus V1 and plus V2 because plus sign here also encountered first. Now what is the value of V1? According to the Ohm's law, V1 should be equal to I into R. V1 is the product of current and the resistance. We know very well that the current throughout the resistance R1 is equal to I1 and the value of resistance is 10 ohm, so that's why it will be I multiplied by 10 ohm plus it will be I1 multiplied by 10 ohm plus same concept I have to apply for V2, that is equivalent to I2 multiplied by resistance value, that is 50 ohms, so 50 I2. We know very well that in the series circuit current remains same, in the parallel circuit voltage remains same. So these resistors are connected in the series, so I1 and I2 will be equal. So I am considering I1 and I2 as equivalent to I ampere. So that's why the expression will be minus 120 volt plus current I multiplied by 10 ohm plus same current I multiplied by 50 ohm, that is equivalent to 0. So here I will be 120 divided by 10 plus 50, that will be 2 ampere. So the current flowing in this closed circuit will be 2 ampere. If you want to find out the value of V1, voltage drop across R1 resistance, you have to just multiply the current flowing through the resistance with the resistance value, that is just multiply 2 ampere with the 10 ohm, that is equivalent to 20 volt, and just multiply by 2 ampere with the 50 ohm, that is equivalent to 100 volt. And KVL says that the sum of the voltages in the closed loop circuit is always equal to 0. Then V of DC will be equivalent to V1 plus V2, as we have found out the value of V1 is equivalent to 20 volt and V2 is equivalent to 100 volt. So 100 plus 20, that is equivalent to 120 volt, and it is equivalent to the voltage source. This is active voltage source, active element, because active element is the element that is able to give the power to the entire circuit even for higher amount of time also, not for short amount of time, like L inductor. Inductor stores the electrical energy in the magnetic form and it delivers the power, but for a short time of period. So that's why it cannot be say as a active element, it will be known as a passive element. Okay, so this was the example. I think the concepts regarding to KVL and KCL have been cleared on the basis of this example. Okay, so next, coming to the next slide, I have already told, I have just attached this slide just for your revision purpose. Okay, this is the voltage source, this is the resistance, P is the power dissipated across the element. We know very well that resistance is the power dissipating element. Okay, and it can be the properties of resistance, applications of the resistance is we use in the like in the areas where we have to develop the heat. Okay. So in the iron we use the resistive property, we use the power dissipative property, okay, where we need to have heat for just our clothes. Okay, so V, according to the Ohm's law, V will be I into R, so P will be I into V, that is equivalent to I square upon I square multiplied by R. Because V is equal to IR, we have to put the value of V in this respective formula. So I multiply by R, that is equivalent to I square R. And we also know very well that I square will be positive always, R will be positive, so power will be positive. So that's why that means power will be positive. Okay, so as the power will be positive, that means the resistor is the element that is going to dissipate the power, that is going to absorb the power. Okay, so it will be passive element, it is not active element. Now come to the next slide. This is current division rule. Whenever current has to be divided among the resistors in the parallel, use current division rule principle. And whenever the voltage is going to be divided among the resistors in the series, use voltage divider rule. This rule says that R1 and R2 are connected in the parallel. I1 is the current flowing through the resistance R1 and I2 is for R2. Is the total current and Vs is the active element, that is voltage source. Okay, so what will be the value of I1 and what will be the value of I2 if Is is the total incoming current and R1 R2 are the respective values of the resistances. Okay, so if you find out the value of current I1, so I1 will be equivalent to R2 upon R1 plus R2 multiplied by total incoming current, that is RS. And if you similarly you can find out the value of I2 by just putting the value in this respective formula, that is I2 will be equivalent to R1 plus R2 multiplied by total incoming current IS. Okay, so if you find out the current flowing through this resistance, take other resistance in the numerical, okay, in the numerator, then take the sum of those both the resistance in the denominator, R1 plus R2 multiplied by total incoming current IS. Okay, so just apply this formula, you will definitely solve the questions. Now coming to the next slide, this is the actually circuit. Okay, I will not solve this circuit, you have to solve this circuit. You will definitely solve the circuit if you